Hello everyone, this is a video lecture for College Algebra Math 1314 Section 3.3, Long and Synthetic Division. So, let's get right to it. We've got a long division problem. It even says use long division. And so, let's do long division. This is going to take a while, so here we go. I got 5x minus the 4, and we're going to divide this 20x squared minus x minus 9. Okay, that's how I set it up. And let me go through all of the procedure, every step. Here we go. I'm going to take the leading terms off to the side, and I'm going to divide them. So I take these two leading terms, and I'm going to divide them on the side. And so 20 over 5 makes a 4, and then x squared over x is just an x. And so I'm going to put that right here in the x's column. Notice we got the x squares, the x's, and I'm going to have regular numbers. So I'm trying to line it up. Not really required, but it definitely will help. The next step is to take what I just multiplied or just divided and figured out. I'm going to multiply it by each of these terms, and I'm going to bring it down. And so I got 4x times 5x is 20x squared. And then the 4 times 4 is going to be 16, so that's a negative 16x, just a plain old x. See how they're lining up? So I multiply and bring it down. And then I need to subtract. And this is the basic way to do it, just subtract this minus that. And that might work for most, well, for some people. I would say not most. Not for me. It doesn't work for me, so I don't want to assume that it'll work for you. Either. So what I do, yes, we're subtracting, but I want to switch the signs. So that was a positive, now it's a negative. This was a negative, now it's going to be a positive. So I switch the signs. What I'm doing with the subtract for the whole thing is distributing it. But if you just switch the signs, it should be fine. So 20 minus 20 is 0, and you should always get a 0 here. Always, always, always. If you don't have a 0, you did it wrong. You got to go back and do something else, okay? So that's kind of like a double check to make sure you did it right. Right here, though, we got negative x, and then plus 16x makes a positive 15x. And then the last step is that you're going to bring down the next term, and you start all over again. And so here we go again. Take the leading terms off to the side. 15x over 5x. So you got a 3... The x's cancel, so it's just 3, and that's a positive 3. So plus 3, positive 3. I'm going to then multiply. So multiply the 3, distribute it, bring it down. So 3 times the 5 is a 15x, and 3 times the 4 is going to be at 12, but it's now a negative. Switch the signs, so negative. 2 negatives make a positive here. 0 it out. And then here we would have a 3. Sorry. And there's nothing else to bring down, so what this is your remainder. That's your remainder. And this up here is called your quotient. And so there could be a few ways that the homework program's going to like show you all this. The one way is to have two separate boxes that'll look something kind of like this. And so this is supposed to be your quotient and your remainder. They won't say that, but I'm telling you. And so what you would put in is the 4x plus 3, and then a 3. And then you're done. Sometimes the homework program a single big box, and you have to type everything kind of like freehand style. This is not hard, so you just type quotient, that's your answer, and then you want to add your remainder, but your remainder remained behind. It remained behind with this division stuff, okay? So if you have to type it all together at once, it's not too bad. It is definitely possible to do so. Okay, cool. So let's do another one. That was a lot of colors. Let's do another one. So this is still long division, and we have to figure it out. And so let me go ahead and write each of these terms out here. Get a little bit of room here. So we got 7x cubed minus the 5x squared plus the 2x plus the 6. Okay, I'll try to use the same colors from last time. So take the leading terms off to the side, divide them. Well, the 7's cancel. A lot of the x's cancel except for one of them. Notice that's just going to be a plain old 1x. And I'm trying to put it in the x columns here. So that was good. I'm going to multiply that x by every single one of these terms and bring it down. So x times 7x squared is 7x cubed. X times the 2x is a 2x squared. And then x times the 6 is a 6x. I'm then going to subtract everything. But now that would be hard to do, especially at this point. So I'm going to switch the signs. Negative. This was a positive, so now it's a negative. This was a positive, and so now it's a negative. Let me just try to make it look a little cleaner here. There you go. I want to use that color, but there we go. There, minus. It's easier if you had like a pencil. So zero it out, of course. And so what we have here is a negative 7x squared. Here we have a negative 4x, and then I'm going to bring down the next and last term here for this problem, and then repeat. And so take the leading terms off to the side. Negative 7x squared over 7x squared. Result, so negative 1, negative 1. I'm going to multiply that through. So multiply it, distribute, bring in negative x squared. I got a negative 2x and then a negative 6. Switch the signs, and so didn't want that 6 to change. Positive, positive, positive. So that's zeroed out, of course. That's good. That's double checking. Everything's fine. Here we get a negative 2x, and these guys actually combine together make a 12. There's nothing else to bring down, so that's your remainder. Even if it looks a little bit bigger than the last time, it's still your remainder. So this is still your quotient. This is still your remainder. And I'm just going to finish this thing off so we can feel good about it. I'm going to use the 2-box method because that's the most common. If you had to type this all out, I guess you could. I mean, it's not any different. It just, you would have to type the whole thing, which would take a while. Such a tiny little box. Okay, close enough. So again, quotient, remainder. And there we go. That was it. That's the entire problem. So that's long division. Let's do some synthetic division problems. And so they actually say use synthetic on this. I didn't spell it right. Synthetic division. They say to use synthetic on this one, but you can actually use it on a few other ones. Not every single problem you can use it. If it says long division, use long division. Seriously. If it says synthetic, go ahead and do whatever you want. So synthetic division is actually really easy and it's quicker, but we're going to do it a lot as we continue on. But let me show you how it works. First off, before anything else, I need to solve for x on the bottom. So I need to solve for x. And this is super easy. It's x equals 2. I call it kind of like my 0 from the bottom. Another name that you can give it is pivot. Maybe that's just my term. I don't know. I'd like to call it pivot. But it's an important number, and that number, that 2, you're going to put right here, and you're going to box him off because he's super important. And then to continue with the synthetic division, what you need to do is write the coefficients for the, I guess, the top part, the numerator. And so we would have a 4, and then, hold on, you'd actually have a 0 here. And then a negative 5, a 3, a negative 2, and a 3. Now, hold on. 4, negative 5, 3, negative 2, 3. They look good except for that 0. Where'd that guy come from? Well, notice that if you go here, we got a 5 and then a 3. So I guess in the middle, there must have been a 0x to the 4th. And if there is anyone missing like that, even if it's long division, we need to put that kind of stuff in. I like to call them placeholders because they hold a place. So it's very important to do that. And how I personally often make sure that I don't mess up is that I actually write like an x to the 5th, an x to the 4th, an x cubed. Everything I'm writing here is not required. It just reminds me that I had every single one accounted for, okay? So I'm just double checking myself, that's all. And then what you do for synthetic division is you bring down the first number and then you start this process. So let me show you the process, very simple process. First off, 2 times the 4 is 8. That's multiplied. 2 times 4 is 8. And then you're going to say 0 plus 8 is 8. And that's all. Multiply, add, multiply, add, multiply, add, all the way down. 2 times 8 is 16. Negative 5 plus 16 is 11. 2 times, oops, I want to use the same colors if I can. 2 times the 11 is 22. And 22 plus the 3 is 25. 2 times 25 is 50. 50 minus the 2 is 48. 2 times the 48 is 96. Plus the 3 is 99. And that's your remainder. The last number here is your remainder. Okay? Now everything else is a quotient. So let me go ahead and extract what your quotient would be. It's all this stuff. Now notice that we started with x to the 5th. Now this is going to be x to the 4th. This was x to the 4th. Now it's going to be x cubed, and so on and so forth. So this is 4x to the 4th plus 8x cubed plus 11x squared plus 25x plus 48. Again, that's all your quotient. And then your remainder, well, I guess you don't have to box it. It's already there. It's just 99. Again, sometimes you get a 0, and that's nice, but here we got 99. That's fine. It's just a number. Doesn't really matter. There you go. 2 boxes. You fill it in however you need to do it on the homework program. So the main thing, multiply, add, multiply, add, multiply, add, all the way down. So that's synthetic. They want you to use synthetic here again. They say use remainder theorem, but really they're trying to say synthetic division here. And so we're supposed to use this 1 with synthetic division, and it's going to be a 5x cubed negative 12x squared 5x and then a negative 4. Okay? Again, you do not need to write the x cubed x squared x. I'm doing that for my sake. I'm doing that so I remember what I'm doing. Because down here, this is going to be x squared. This is going to be an x. This is going to be a regular number. Okay? But let's go ahead and just, do the math. So 1 times 5 is 5. And negative 12 plus the 5 is a negative 7. So again, multiply, add. 1 times the negative 7 is a negative 7. With the negative 5, we'll make a negative 2. Negative 1 times the negative 2 is a negative 2. And minus 4 is going to be a negative 6 in the end. And so that's your remainder. And you know what they actually want here? It's just the remainder. It's the remainder theorem. But if you zoom out for a second here, what are they asking for? Look right here. What are they asking for you to do? Well, honestly, you didn't have to do any of it. They just want you to plug in a 1. And so if I just plugged in x equals 1 everywhere, I got 5 times 1 cubed minus 12 times 1 squared plus the 5 times 1 minus the 4. So that's 5 minus the 12 plus 5 minus 4. I'm going to get my calculator out just to verify here. I want to make sure I don't mess something up here, 5 minus 12 plus 5 minus 4. And yep, guess what? Negative 6. Wow. Could I have just plugged it in to begin with? Yes, but I wanted to practice more synthetic division with you because we'll be using it a lot. Okay, so either way, plug it in or synthetic, you'll get the same answer. It's just a formula, a coinkydink, it's a theorem, I guess you can say. All right, and this is actually the last question, and it uses synthetic division as well. Notice that there's a whole ton of decimals going on. So we got this rectangle. Let's say the area of the rectangle is this, and the width is this. Find the length. Well, the area is length times width. So to be able to find the length, you divide by width on both sides. And you can see why we're in the division section here, because you're going to have find the length as area divided by width. So all this area divided by this thing. Here we go. And definitely synthetic division. So if I'm going to solve for x here, what would I get for this guy? Again, you're just switching the signs. Negative 0.9. So negative 0.9 is your pivot, is your important number, your 0. And then you got to write the coefficients for all the other ones. Just like this. Now, I don't know about you, but I don't do a lot of decimal math day to day. Fractions are actually easier to me at this point. So 9 times 7, isn't that like 60-something? But the point is that I'm not doing 9 times 7. I'm doing 0.9 times 0.7 should give me a 0.63, okay? And what I mess up most on is just trying to do it by hand. I tell you right now, I'm holding a calculator in my hand right now. And I'm going to do every one of these with a calculator. So positive 0.43 minus the 0.63 is negative 0.2. Negative 0.9 times the negative 0.2 is 0.18. Two negatives make a positive. 0.22 plus 0.18. Even if I know the answer, I'm still using a calculator. 9 times 4, you can guess now. It's 36, and they should cancel, make a 0. That's how it should work in the homework program. And so my answer then is just down here. Remember, this is x cubed. Now this is going to be an x squared. So here's your final answer. 0.7x squared minus the 0.2x plus the 0.4. And there you go. That's your quotient. That's your length. You're done. You just did it. Okay, now I know I did not do all of the problems on this homework section. Of course not. I can't do every single one every time. But the other ones remaining are basically synthetic division in some way or another. So don't overthink it. Try to be kind of easy with it. Maybe use a graphing calculator if you need to, depending on the problem. So that's all I got. Thank you very much, and have a great day.